Every now and then we hear that the Earth is getting warmer. Actually, it has become a huge concern for many of us. Sadly, a while ago, I came across this unwelcoming and unsettling piece of news in The Guardian. El Niño is back. Hi, welcome to Eco Concerns. My name's Amir. Our life on Earth is influenced by many cyclic variations. We've got day and night cycle, solar cycle, the ebb and flow of the tides, carbon and nitrogen cycle. Well, the majority of these cycles can be predicted and their possible adverse consequences can be dealt with to various extents. However, there are a few cycles that can neither be predicted nor averted. One of these cycles is the El Niño Southern Oscillation, which is commonly known as El Niño-La Niña cycle. This climate cycle takes place in the Pacific Ocean. However, its impact can travel far beyond its origin place and can be felt in many areas on the Earth. El Niño can bring on drought, famine, flooding, and mass die of marine life. For instance, in 1998, El Niño destroyed approximately 16% of world's coral reefs, which instigated a cataclysmic mass bleaching that has continued to this day. So let me explain what El Niño-La Niña cycle is. Well, El Niño Southern Oscillation, known as ENSO, is a weather phenomenon that takes place in the eastern tropical Pacific every 2 to 7 years. In order to understand how this phenomenon is formed, we should first know what's commonly happening in tropical Pacific. The dominant wind direction in the Pacific Ocean is westward, meaning that generally, wind travels from South America towards Asia and Australasia. So typically, the upper layers of the ocean are hotter than the layers beneath. This is because they receive heat from the sun. As the wind blows westward, it pushes warm layers of water towards Asia and Australasia. So after some time, these warm layers pile up in the western side of the Pacific Ocean near Australia. On the eastern side of the Pacific Ocean, however, we've got a different story. So as the warm layers of water are pushed away from the coastline of South America, the cold water layers beneath, deep in the ocean, get the chance to come up and replace them. So after some time, a cold water zone is created near South America. This process is known as upwelling. Just so you know, the cold water coming from underneath is rich in nutrients and feeds phytoplanktons, which support the whole ecosystem of the area. This highlights the significance of this natural process and tells us that any shock to this system can cause major domino effect on real life. So when we have a warm water zone to the west near Australia and a cold water zone to the east near South America, a temperature difference, a temperature gradient is formed across the tropical Pacific. The warm water in the warm water zone adds extra heat to the air and causes it to rise. As the air rises, it creates an area of unsettled weather, and thus clouds and rain are formed. So this warm weather, this warm air, starts moving towards South America, moving eastward. And as it does, as it moves in that direction, it cools down, becomes dry, and descends. In a normal condition, a self-perpetuating circulation is formed across the Pacific Ocean. One of the bases of this circulation, as I mentioned, are trade winds. But the thing is, the strength of these winds is not consistent. Under some circumstances that I'm not going to elaborate in this video, the strength of these winds may become less. They may get weakened. And so what's the consequence? As a result, we will have less push of warm water towards Australia. This means, consequently, as there is less push of warm water, there won't be any chance for cold layers of water underneath to come to surface. This means that we will have less upwelling. So as a result, there won't be any cold water zone forming near South America. So what happens is that we won't anymore have a cold water zone to the east near South America. And plus, the warm water zone expands across the Pacific Ocean and cancels out the temperature difference in the Pacific. A change in the place of warm water zone in the Pacific means a change in the area of wet and unsettled weather. This means that wet weather that in normal condition used to be formed close to Asia and Australia is now formed somewhere in the heart of the Pacific Ocean. This changes the rainfall patterns and wind patterns across the equatorial Pacific. But the impacts of these changes are not limited to that region, are not limited to Pacific Ocean. As a matter of fact, it can be sensed in many regions all around the world. But the major impacts take place in the Pacific Ocean. As a result of this change, we've got actually an increase in the level of flooding risk in Peru. So there is actually more likelihood of flooding taking place in Peru. But on the other hand, there will be a risk of drought and plummet in the level of rainfall in India and Australia. So what El Niño has to do with global warming? Well, when El Niño is formed, the vast area of warm water extended across the Pacific releases massive amount of heat to atmosphere. As a result, we experience a rise in the average global temperature. In 2016, the last time that El Niño occurred, the recorded global temperature was approximately 1.1 degrees Celsius above the pre-industrial values. The thing is, the impact of El Niño is not as significant as you may think, but it is still enough to be considered, to think about. For example, the contribution of El Niño in 2016 in the rise of global temperature was 0.2 degrees Celsius. Typically, El Niño years have featured among the warmest years on record throughout the history. El Niño typically takes place during winter time, and it takes months for it to turn back into normal condition. But at times, there are some times that El Niño is reversed and turns into La Niña. So do you remember what was the reason behind El Niño? Yes, the trade winds getting weaker. But there are times, fortunately, that these trade winds may become stronger. So what happens? We will have a stronger push towards the west. So the warm water layers are pushed to the far western side of the Pacific, and they will form a warm water zone on the other side of the Australia, close to areas such as Vietnam and Indonesia. And as a result, there will be a higher chance for cold water zones underneath to come up. So we will have a stronger upwelling phenomenon in the eastern side of the Pacific Ocean. As a result, we will have our cold water zone enlarge in that area, and it may even extend towards the heart of the Pacific Ocean. Just like El Niño, La Niña can have an impact on average global temperature. But how? Is it in our favor or against? As I said, La Niña is the flip side of El Niño. So it means that unlike El Niño, La Niña is capable of lowering the average global temperature. We cannot precisely predict when El Niño or La Niña take place. Well, unfortunately, the timing is erratic and dependent on a complex multivariational interaction between different climate systems, including current dynamics and thunderstorm cloud formation. Currently speaking, we are at the end of a 3-year-long La Niña period, and according to the recent observations and data, unfortunately, El Niño is on our doorstep. That's why 2003 and 24 are expected to be experiencing a rise in average global temperature. So this is the end of the first video on my channel Eco Concerns. My name's Amir Mostashari and I wish you best of luck.